dissecting solution concentrations. So if you are struggling with reading over the word problems and trying to find what information that you have, that you are provided, and what information you need to find, yeah, take a look through this video here. So the learning goals today are to solve concentration problems where of various solutions, and usually they're going to involve calculating the mole of something. And yeah, you're going to end up working with various concentration units. So for example, we have mole per liter, which is amount concentration. We have this gram per 100 milliliters of water, which we've seen with solubility, parts per million, parts per billion, parts per trillion, which we've seen with very, very dilute solutions. And then we've seen some percent concentration, where it's percent volume or percent by volume, percent weight per volume, and percent weight per weight. Okay, so there's lots of different units for concentration, but really in the end, we're trying to measure how much solute is in the solution. Okay, so yeah, we're not always going to find concentration though. We might need to find some other piece of the puzzle. So I'm just going to go through here and summarize the different types of concentrations that you should have studied already. Okay, so the first one we started off with was the amount concentration here. Here's the general formula. We have moles, amount in moles divided by the volume in liters. Okay, so again, so yeah, that concentration, you should end up with a unit of mole per liter. Okay, and again, it's the common one that we use as chemists in labs. Okay, so from there, we learned some percent concentration as well. And again, all of them, it comes down to, like, even with the mole over volume, it came down to how much solute, so what amount in moles of solute you had compared to how much volume of the solution. Okay, so that's the theme here. It's always solute over solution, solute over solution. So with the percentage, what you're going to find is when you make that comparison between volume volume or mass volume or mass mass, you're always going to multiply that ratio by 100 to get a percentage value. Okay, and then these should be your units. All right, so you would say, 5% by volume, or V/V. And then for very, very dilute substances, we're going to use the parts per type concentration. So here's parts per million, parts per billion, parts per trillion. So same thing, it's mass of solute over solution, and then you're going to multiply by 10 to the 6 if it's million, because that's 10 to the 6 is a million, or times 10 to the 9 times 10 to the 12. Okay, so again, these values here out of these ratios here will be so tiny that we just need to kind of bump it up and put it in the millions, and so that it's kind of more of a reasonable value that we can place on labels and so forth. Okay, or report it in reports. We don't want something super tiny. All right, and then the last one is a solubility. We looked at various solubility graphs in order to figure out how much solute there is in 100 milliliters of water or 100 grams of water. Okay, so again, just another type of concentration, but in the end, you are taking the solute and you're comparing it to the solution. All right, so what I want you to do here is get comfortable with, okay, so if you have this type of concentration, this is the unit that you should have. If you have this concentration, this is the unit you should have. So you're looking for the units when you're reading over, the problems that are coming up. And so you can identify, oh, it's a concentration first off, and then from there, what type of concentration it is. Okay. All right, so from there, we have other units that you have to watch out for. So if you ever have something like liters or milliliters, you want to, you want to be able to identify that as, oh, that's volume, okay? So and the thing is, it's not, if you see mole per liter, that's concentration. But if you just see liters by itself or milliliters, then you know it's volume. Okay. All right, the other one I want you to watch out for is mass, okay? So again, chemists refer to mass as weight, which is, it's incorrect, but we're just going to point out that you'll see them and then just use them interchangeably in chemistry, but yes, it's not something that's correct if you're a physics student, right? So anyway, so just kind of roll with it. We use it incorrectly, and it's used like on different chemicals and medicinal products and so forth. So just kind of use them, yeah, just be able to identify both. Okay, so the units that you're going to see with the problems are things like grams, okay, kilograms, milligrams. So again, be able to recognize that, oh, that's a mass that I have. All right, then from there, the last thing to watch out for, I know there's a lot of things here, but the last thing to watch out for is, yes, it might be talking about concentration, it might be talking about volume, all that stuff, but if you see the word diluted, okay, the solution is, watered down or diluted, then we know that we have some sort of dilution problem, okay, so that's when you have to kick in this formula here, okay, so, but yeah, for most of them though, it's going to be solute over solution, okay? But again, you could use one of these concentrations up here in a dilution question. Again, you can do that as long as all the units are the same. So if you need to find something in parts per million, you can use the dilution formula here, okay? If you have to find the missing concentration, it's going to come out in parts per million. Okay, if you have liters, you want to work in liters, right? So the main thing is be consistent with the units. Okay, so now that we've kind of just gone over the different I guess the keywords or the variables or the information that you're going to look for in the problems, let's actually look at some simplified examples. So here on the next page here, so I have a table here of just information that I've just created. So if you had a word problem and you saw these numbers coming up, what I want you to do here, I know we don't have the context, but just for now, I want you to be able to look at the unit and identify, oh, that's what is its mass or its volume or its amount or its concentration, okay? And if you can be more specific, like it's a parts per million concentration or it's a percent weight per weight concentration, be able to state that as well, okay? So as much possible information as possible, even though we don't have like a kind of a sentence or a backstory here. Okay, so take a look at those. So what you can do is pause the video, take a look at the items in the table, and yeah, just fill in what you see. So the first one is 15 grams. Okay, so right away, grams, I'm able to identify, oh yeah, that's a mass. Okay, so you can write in the general term, but if you can get to the point where you could just write the symbol, just so that you can identify something quickly. Okay, so I would write m equals, so here if I even did it this way, so I would say m equals 15 grams, like that. Okay, all right, the next one we have, again, 7 mole per liter. So again, get to the point where you're like, oh, it's not moles like amount, but it's mole per liter. Oh yeah, this is concentration. Okay, so, and then this is amount concentration. Okay, so amount concentration. I'm just going to abbreviate here because it's not going to fit. Okay, all right, so that's just, like the letter C and 7 mole per liter, like that. I guess you just stack them up again. Okay, go to a different color here. Next one, 400 milliliters. 400 milliliters, it's the same thing. Looking at the unit, okay, and going, oh, okay, that's volume units. So volume, okay, and what letter is that? V, okay, capital V, 400 milliliters. Okay, so the reason why we're trying to match it with the symbols, I want you to be able to dig information out. So even if you're like, trying to find, you're reading through a word problem and you want to write V at least by an M by the other one, right? You can kind of identify, or you can actually list them off. Okay, next one, 8 ppm. Okay, so again, that's all about being able to identify the different concentration units. So just keep kind of looking at those tables above and figuring out what is what. Okay, so here, this is a parts per concentration. Okay, again, you don't need to identify this, but if it helps you kind of with your learning, I'm just putting it down here. But really, this is a parts per concentration, 8 parts per million. Okay. All right, so the main thing here, even if you're like, can't remember the C subscript ppm, as long as you're putting C and you understand that it's concentration, that's good, okay? All right, but yeah, like if you can identify that, oh, you're noticing it's a specific type of concentration, it's good because then you can select the right formula to use, okay? Because remember, you're going to be given, this table here. You're going to be given this table here, well, a similar table where you just got the formula and so forth, right? And you got those symbols and you know what it's called, right? The units, I won't give you the unit part, but Yeah, you should be able to use all the information there in order to um, identify what you have. Okay. All right, and then therefore lead to the equation. All right, so next one, we have 6% volume. Okay, so that's percent volume, so percent concentration. Okay, so that will be a V slash V, 6% V slash V. Okay, so key things here, yes, identify the concentration, identify the volume, identify the mass, etc. Okay, so again, here's liters. So I have volume. Actually, maybe I'll color code these. Okay, so here's everything color coded. So we had a couple masses. So anything with grams, milligrams, kilograms, right? Those are masses. So I have those here in green. Any volume, so milliliters, liters. You can obviously have other types of liters, but these are the main ones you'll see. So those ones are the letter V for volume, right? So again, if you're not a symbol person, you don't like to, remember it by symbols, please just be able to recognize the unit and understand, okay, I prefer to write the word mass, then that's fine. You don't have to write M, okay? From there, the rest are concentrations. I see a mole per liter here, right? Every time you see a mole per liter, that's amount concentration, right? So we have the moles over the volume liters, okay? And then we have the percent concentrations, right? By volume, volume, or weight here. So yeah, the percent concentrations, the amount concentrations, and then we have um, parts per million, parts per billion, parts per trillion concentrations as well. Okay, so those are kind of like the most of the ones you'll see. Remember though that you can also see the solubility ones that can appear as well, but you will actually find that the mass per volume is going to be it's very similar to it is like the percent, okay? So because you're just taking mass, comparing it to volume, but then if you convert it into a percentage, because you're going to get a decimal here, or just a smaller number, you can multiply by 100 to get the percent, okay? So it's actually just like the percent here. So, all right, here we go. So now, so keeping that in mind, okay, so remember it's mass of solute over um, mass of solution, or volume of solute over volume of solution, or you might have mass of solute over volume of solution, okay? So you're trying to identify all of these different pieces of information here. Okay, so so instead of just having some sort of value with some units, we're going to put it in with some context here now, and put in a word problem. Okay, so here is again, just the reason why it's numbered funny is because it's to match the other video I made. So anyway, we have what's called problem 5 right now. As our first problem. Okay, so we have a photographic stop bath that contains 140 milliliters of pure acetic acid in a 500 milliliter bottle of solution. Okay, so what is the percentage by volume concentration of the acetic acid? So what I want you to do here in order to get better at reading a question, finding the information, is go in these steps where you're trying to find what's given to you, then find what it is that you need to find. So what's the unknown? What is the purpose of the question? And then from there, set up a plan. Okay, you're going to use these equations in order to get to the answer. Okay, but we're not going to go to the answer. We're just trying to get ourselves set up, because going to the answers may be the easy part here. Okay, so what I want you to do is get a highlighter and highlight the information that is being given here. Okay, so I have 140 milliliters of pure acetic acid. Okay, so I don't know, I guess I could just keep highlighting there. I have a 500 milliliter bottle of solution. Okay, so same thing. There we go. Okay, and then what is the percentage by volume concentration? That's what we need to find here. Okay, so what we have to find. Okay, so let's go through and pull this information out of the problem. Okay, so what I want you to do first is, again, look at the values that you're given. Look at the units to identify what it is that you have, okay? So right now I see milliliter, I see a milliliter. So right away I'm just going to put V for volume for both of these, okay? And then from there you can decide if there's more specific volumes like solute and solution. And then here's the concentration that you have to find. So again, remember concentration is C, okay? So for now, just start with those letters. Start with those letters, identify what they are. Okay, so from here, let's look at it more specifically. So this is percentage by volume concentration. Okay, so that's all it's given, volume. So if that's the case, it's the volume one, okay? So if it's percentage by weight, then it's the weight one. But otherwise, if it's weight volume, it would say weight volume. Okay, so again, looking up here, we are looking at this one here, okay? It won't be these other two. All right. So from there, we have a couple volumes here. Okay, so I want you to look through and figure out, okay, so what kind of volumes can you have? You can have a solute and a solution. All right, so again, the solute there's a smaller amount of, okay? The solution will have the greater amount. So in this case here, we have the 140, so I'm going to call this the solute volume, and this will be the solution volume, like that. Okay, so dissect that problem, dig the stuff out. Okay, so once you kind of start digging stuff out, maybe get in the habit of doing this, and then once you get better at solving the problems, you can kind of stop doing this, okay? So right now, let's just list off everything we have. Okay, so there's the volume of the solute, it's 140 milliliters, okay? And then we also have the volume of solution. Okay, so that's the larger amount, a larger volume, and that's the 500 milliliters. Okay, it doesn't say, but it is water. Okay, that is making up most of this. So the solute of acetic acid is going into water, mixing up and making a 500 milliliter solution. All right, what else do we know? That's it. Okay, so what do we have to find? We have to find the concentration, which is percent by volume. Okay, so again, if you at first uncomfortable with the symbols, but you want to use them, there's nothing wrong with writing a little bit more info here to get so just so that you can identify what you need. So percent by volume concentration. That's what we need to find. Okay. All right, so once you find all those items there, I want you to now come up with a plan going forward. So we do need to find the concentration. We have this information here. What kind of equation can we use here? Or sometimes it's more than one equation. So going back up here, we have volume, and we need a concentration. So we're looking here, and we see that we have this is the volume concentration. So here is the formula, okay? So you can add that into your plan here. Okay, so there it is. Okay, so our plan here is we're going to use this formula somehow to find our information. Okay, times 100. Okay, and this will lead to the percentage, okay? I know on the other sheets I had the percent there, but it was confusing some of you to have the percent there, like you thought you had to hit the calculator percentage, but no. So I just dropped it, but just know multiply by 100, but your answer should be a percent, okay? Like that. All right, so we're not going to solve it, but if you did want to continue, you just like plug everything in. You know the solute, you know the volume solution, so take them, divide it, times it by 100, and you'll find your concentration. Okay, here's the next one. It's a silver ring, has a mass of 12 grams. So just highlighting everything I have, 11 grams of silver. Okay, so that's pure silver. And then this is the mass of the ring. So the ring has a mass, okay? All right, and then what do we need to find here? What is the percentage weight by weight concentration, okay? All right, so let's go through. First, just kind of write some info here. So mass, grams, right? So we know mass, mass, grams again, we know mass, okay? And we have a percent weight by weight concentration, there's C. Okay, so from there, let's look more specifically at, what kind of masses do we have here? So we have a ring that's 12 grams. It has 11.1 grams of pure silver in it. Okay, so we're looking at a solid mixture here, our solid solution. So we're going to have this will be the solute. There's less of this, and then this is the overall, right? So solution. So again, you can even have a solid solution, right? And let's hear. And then we have our concentration. So it's weight by weight, W/W, like that. Okay, so let's list our information here. Okay, so here is all the information listed now, so it's nice and clear to see. So solute's 11.1, the solution, okay, the overall is 12 grams. We need to find the weight per weight concentration. Okay, so we'll go to our table here, weight by weight. It is looking like this one here. So mass of solute over solution times 100. Okay, all right, so again, we'll solve it later, but you just want to kind of set the question up once you kind of know what to do here. Just plugging it in and finding the missing value is not too bad. Okay, so I think the hardest part here is just deciding, do you have mass? Do you have volume? Do you have concentration? That's what we got to figure out, okay? And sometimes you can have moles, right? Amount to moles. All right, next one. Okay, so we have some pool water here. We have 1.5 liters of pool water sample here, 4 milligrams of chlorine. Determine the concentration in parts per million. Okay, so let's highlight everything here. Here's the pool water. Here's the chlorine. Find the concentration of chlorine in parts per million. So again, let's look at the units. I have liters here, so I'm like volume. Okay, I have milligrams, that's mass. Concentration of, this is C. Okay, so from there, let's list off what we have and figure out what our plan is. Okay, so here's all the information now in our boxes here. So again, remember this is the pool sample. We had 400 milligrams of chlorine in it. So this is the solute. This is the solution. Okay, and we want to find a concentration in parts per million. So concentration parts per million. Okay, so those are given, and whoops, unknown information. Okay, all right, I'll fix this in a second. So for now, what I want you to do here is so we know our parts per million formula is this. Okay, so we're looking here and like, okay, it's going to be mass over mass over mass. Okay, so in that case here, what's going to happen here is, see how we have a mass of milligrams, and then we have a volume in liters, right? So you're going to have these stacked up. So the solution has to be in mass, okay? And right now it's liters, so we're not a mass. And then on top of it, you're going to have, so you have milligrams, you're going to, here, so let's start with getting this converted over. So the reason why I want you to get the liters to milliliters is that we looked at how water, the density is 1, right? So water's, so the density of water is 1, okay, gram per mil. So since the density of water is 1, you can use this relationship. So every 1 gram of water has a volume of 1 milliliter, okay? So we need to get everything to grams here in order to get, because remember, you can divide by the same, you can divide things here as long as they're the same units, okay? So we're just going to move towards to grams, okay? So here, we're going to change this to milliliters,
Okay, so we're going liters to milliliters, which is smaller, so we're going to multiply by 1,000. Okay, and then you're going to get 1,500 milliliters like that. Okay, so we're in milliliters. And the cool thing is, we know a milliliter is the same as grams. So I can change this to grams. Okay. All right, the next one. So now that we're in grams, we want to have the same units for mass. So let's change milligrams to grams. Okay, so what you need to do there is you're going to divide. Okay, and 5,000, and you'll get this. Like that. Okay. All right, so now we have everything in grams. Now we can divide it, and then it should work out here. Oops, I need another 0. There we go. Okay. All right, so now when we go mass divided by mass, the grams will cancel out. Times it by the 10 to the 6 parts per million, and then we're going to get a parts per million unit at the end. All right, go to the next one. Okay, try all the different ones to get good. Okay. All right, final concentration of, what is final concentration when you have this volume? Whoops, 125 milliliters, 30% weight volume, and it's diluted to 2 liters. Okay, so lots of information here, more than we had before. Okay, so from here, you see the word diluted, right? So right away you're like, oh, it's a dilution question. So even if before finding the given and unknowns, you can pick out that formula that you need. Okay, so you have the concentrated side, the diluted side of this dilution formula. All right, so from there, now work on like trying to identify all the information. So again, I just go in, I don't really read the problem, I just look at all the units, can identify them, volume, percent, weight, volume, oh yeah, that's concentration, okay? All right, so then now I'll read through the problem and I'll look at what it is that specifically that I have. So I have, what is the final concentration? So we have to find this, final concentration. So again, that one's a C as well. Okay, what's the final concentration when 125 milliliters of 30% weight per volume? So this volume, this concentration of hydrogen peroxide is diluted, watered down, right, to 2 liters. Okay, so we have our concentrated, we have our diluted, okay, and we have our final concentration. That means this is the watered down one. Okay, so again, sorry about this label, I'll fix them in a sec. So we have our diluted concentration, that's our goal, but we have our concentrated volume, 125 milliliters. We have our concentrated concentration of 30%. So we start the solution with this concentration, and then we're going to water it down. So then we have a final volume of 2 liters. Okay, so there we go. So we found the information we need. We found the information we need to find. So it's a little bit of tweaking here before we roll into the question. Okay, and use the formula below. So again, with these ones here, the key is you can have, you don't have to have mole per liter for the concentration, but you just have to be consistent here. If you're going to use milliliters, use milliliters. If you want to use liters, change everything to liters, okay? So in this case here, we can just change, everything to liters. I think that's your preference, right? So divide by 1,000. 0.125 liters, okay, and then the units here, okay. All right, so that's this is what you need to find, and that's the formula that you're going to use. Okay, so moving on to the next one here. I've kind of gone ahead and started highlighting all the numbers that I see, and then I'm looking through and finding what it is that I need to find. Okay. All right, so now I'll go through the process of, identifying specifically what I have. Okay, so I have a 750 milliliter, so volume, 13.5% volume concentration. All right, and then it says, so the concentration of ethanol in the bottle of wine is this, assuming that wine has the same density of water, calculate the volume of ethanol in the bottle. Okay, so here we go, we have our volume concentration, PV, and we have our volume of the bottle, and we want to know how much volume is in the bottle of ethanol is in the bottle. So this is the solute. This is the, let's assume the wine is right up to the top, okay, 750 milliliters, so solution. Okay, all right, and then start thinking about what formula do we need here. Okay, so this is what we have to find. Oh, hold on. What is it that we have to find? It says calculate the volume. Sorry, we need this one. We need the volume of the solute, or, if it helps you, you could just write, ethanol. Okay. You can use these, you can use whatever letters you want, okay? But if you want to learn the ones that I'm using, then that'll be helpful, right? When you're looking at these videos. So, all right, the solution though. So I'm just going to abbreviate, write solution like that. 750 milliliters. Okay, and then the concentration is 13.5%. Okay, so from here we need to calculate the volume. So let's start looking at what kind of formula that we need. So looking at our table here, volume, right? It's just volume over volume like that, right? So volume of the solute's always at the top, solution's at the bottom. Okay, and then this is a percentage, so we're going to multiply by 100%. Okay, all right. So what we're noticing here is that, okay, so we're going to stack the volume up and bottom here, and then we have our concentration here. So because the solute is what we need to find, we can just plug everything in, rearrange it, and calculate it out. So you're going to get a volume at the end. If you decide to keep this volume as milliliters, then you'll get milliliters. If you would like to convert it to liters, just because we're working in liters often, or sometimes we have to work in milliliters, yeah, so just like convert it. But in this case here, if you left it as milliliters, it's okay. All right, next one. Okay, scan through, find that information, find the numbers. Okay, from there, identify them. All right, 5% weight volume concentration. Okay, 125 grams, so that's mass. Okay, so and then it's saying what volume. That's what we have to find. So glucose is used to prepare intravenous feeding solutions. What volume? That's what we have to find. Is of the 5% weight volume glucose solution can be prepared using 125 grams of glucose. Okay, all right, so basically we know the concentration already, we know what mass we're dumping in, okay, and so we're just trying to figure out, okay, what kind of volume do we end up with. So this is the mass of the solute. This is the volume of the solution. Okay, all right, so from there, we have these two pieces of info. Put it in our given. Sorry, 0. Okay, we have our mass of glucose, and then we have our volume of our solution that needs to be found. Okay, all right, so look for your weight volume formula here. Weight volume, there it is, mass of solute, volume of solution. Okay, and after a while you're like, I don't even need to look at the formula. I know the top's got to be mass because it's weight. Okay, and the volume's, the bottom's volume. Okay, that's the solute. All right, and then because this is a percentage, you multiply by 100. Okay, so there's the formula to generate the concentration if you needed to. But in this case here, you're going to have to find the bottom here, the solution. So it's a little bit of algebra, a little bit of rearranging. All right, do we need to convert any units? No, we're going to keep things in grams. Okay, And then when you calculate all of this out, you're going to end up with um, some units um, of grams as well. And then you just convert to milliliters because you need a volume in milliliters. Okay. All right. Next one. Okay. So quickly highlighted the numbers I saw, and then I'm looking at units now. Volume, milligrams, mass. Okay. And this is what concentration? That's C. All right. What concentration of oxygen in parts per million? So that one's ppm. Okay. And again, that's our unknown. So what's the concentration in parts per million? All right, so we have our volume and mass here. So dissolved oxygen in natural water is an important measure for the health of an ecosystem. In a chemical analysis, 250 milliliters of water, okay, at standard ambient temperature and pressure. 2.2 milligrams of oxygen was measured, okay? So again, here's the water. Oxygen's dissolved in it. So mass of the solute, which is oxygen, is 2.2 milligrams. And then we have our volume of water, our solution, is 250 milliliters. Okay, all right, so from there, we will need to use this formula here, parts per million, because that's what we need to find. So when we look at our table, it's going to be mass over mass. Okay, so if you take a look, parts per million, mass over mass. Solute at the top, and at the bottom solution. Okay, but because it's the parts per million, we're going to be multiplying by million here. Okay, but the answer should come out in parts per million for the concentration. All right, so again, remember we need to have the same units when we are dividing here the mass and mass. Right now we have a milligram mass and we have a volume of milliliters. So what you need to do here is get everything to the same units. So we'll go to grams, okay? So in this case here, so if you have 2.2 milligrams, we're going to divide by 1,000 to get to, you're going to get scientific notation maybe on your calculator, but you need to get to here, 123 grams, okay? And then we have 250 milliliters, so we have 0. Oops, sorry, we're already a milliliter, so we're good. So then we're going to use our little trick here. 1 gram is 1 mil, okay, and 250 grams, like that. Okay, so now that we're in grams, we can throw it in our calculations here and find the percent. Okay, all right, next one, we have 12 grams per 100 mils. So this is a solubility concentration, but they're trying to show you here, if it's per 100 mil, you can multiply it by, you can divide this and multiply it by 100 and actually get 12%. So gram per 100 mil is the same as 12%, okay? So here is a concentration. We're going to use that instead of the solubility one here, okay? And then we have a volume here, milliliters, and then it says what mass. So we need M here. Okay, so apple juice, a box of apple juice has fructose, concentration of this, 12%. What mass of fructose is present in the solution? Is present, sorry, in a 175 milliliter glass of juice. Okay, so here we go. We have our solution, right? And we have our solute here. All right, so, and then we need to get to that unit there. So let's get these, oops, that's given. All right, there's concentration. We know the volume, okay, of the solution is 175 milliliters. And then we need to get to a mass of the solute. Okay, so let's look at the formula. What is the weight volume? So it's mass over volume. Okay, times 100. And this is going to get us our concentration, weight per volume. Okay. All right, but what do we need? We need this top value here. We have our volume of our solution. We have our concentration. Okay, so when you calculate all this out, right, because remember there's a percent here, you're going to end up popping out a answer in milliliters, right? Okay, but then because we want to report mass as grams, you can just change the milliliters answer that you get and just change it to grams like that. Okay, so just kind of keep that in mind when you go forward. Okay, next one. People with diabetes have to monitor and restrict their sugar intake. What volume of apple juice could a diabetic person drink if his sugar allowance for that beverage is 9 grams? Okay, assume the apple juice concentration is 12% weight per volume, and that the sugar in the apple juice is fructose. Okay, so here we go. We have our concentration. Okay, so we need to find, and we have our mass, and we need to figure out the volume. Okay, so what volume of apple juice? Okay, and then we have if the sugar allowance in the beverage, so the sugar, the mass of the sugar, the solute, and this is the volume of the solution. Okay, so let's write this down. So mass of the solute, 9 grams. Okay, the concentration. Okay, and then we have our volume of apple juice, which is the solution. This one needs to be found. All right, so here is the formula. So it's mass of solute over the volume of solution times 100%. Okay? All right, so when we go through this, filling everything in, because you see how you have a mass here of 9 grams, when you calculate all of this stuff out, you're going to end up with grams as your answer, but you want to report is the units in liters or milliliters, right? So 1 gram switches over to milliliters. Okay, because of the density is 1 for water. So yeah, so just make sure switch it over and report it in the correct units. Okay, last one. Okay, all right. So again, parts per million. What is that? Concentration. 1.2 liters. That's volume. Okay. What is the mass? That's M. Oh, I should be doing these in red just to be consistent here. Okay, so knowing that, look specifically at what you have. Okay, all right, so we have our sample of well water contains 0.24 parts per million of dissolved iron 3 sulfate from the surrounding rocks. What is the mass of iron 3 sulfate? What mass is present in a 1.2 liter kettle of water? Okay, so we have our solution. We have the iron stuff, 3 sulfate mixed in, so that's the solute. Okay, and then we need a parts per million concentration here, so there's ppm. All right, so let's list this off. So our concentration is given. It's 0.24 parts per million. Okay, and we have our volume, 1.2 liters. And we have our, our volume of our solution. And then we have our mass of our solute that we need to find. Okay, all right, so parts per million, we're going to formula that. You're looking on your table there. Okay, and then you have a mass of solute to mass of solution. Okay, and then times the million there. Okay, all right, so what do we have? We have our concentration. We have our, it's going to be mass. We have our solution, sort of. See how it's in liters? Okay, so but we need to have a mass of the solution. So how do we find that? Well, it's water, right? Water, every 1 gram is the same as 1 milliliter. All right, so right now we're in a liter, so let's get ourselves to milliliters by multiplying by 1,000. Okay, so we get 1,200 milliliters. Okay, and then in order to put it into our equation here, we need to change it to grams. Okay, and you're allowed to do that. All right, so we have our solution and then our mass of our solution. Okay, and we need to find the mass of solute. We do have the parts per million, and then this 10 to the 6 is the million. Okay, so from there, just solve it and figure out the mass of solute. All right, so if you do want to figure out the rest, there should be, I believe it should be a video in where we're just going through and solving it. I wanted to dedicate this video to just practicing, highlighting, finding the information, getting that information from the problem, and then figuring out kind of where to, like, what you need to find, and then how to go about doing it. What kind of plan do you have? What formula do you want to use? What strategy? Do you have to use more than one formula, etc.? Okay, so please practice lots of these.